Hello everyone and welcome. Today I'd like to talk about lowest common ancestor of a binary tree. So you have a tree structure here and you want to find the lowest common ancestor LCA of two given nodes, let's say P and Q. So in this example, you can see the LCA is 3 and we have a 10 here. 10 is a common ancestor, but it's not the lowest. So we return 3 because it's the lowest common ancestor. So how do we approach this question? As in many questions, there are multiple answers. Today, I'd like to talk about a depth-first search method, which may search a branch by going deep recursively before going sideways. Basically, you need a function that will return true if P or Q is in the current node or left or right subbranches. And this function can be implemented in a DFS manner. And this function can be very useful because it provides a way to find the LCA. And there are two conditions that we can find an LCA. The first condition is on the left-hand side. So LCA can be found in the current node if both subbranches return true. On the right-hand side, we have the other condition that we can make sure that we have found LCA. That is when the current node is true and one of the subbranches is also true. With all the background knowledge introduced, now let's write the code. So first of all, we want to remind ourselves the goal here. So we want to define a function that's called DFS and with some argument. And this function will return true if POQ is in the current node or the subbranches. And also two conditions that we have found the LCA. Condition number one, when the two branches are both true. Condition number two, when current node is POQ and one of the two sub-branches is also true. Okay, so now let's implement this. And we put this DFS function like a helper function within this lowest common ancestor function, and POQ can pass on to this DFS function, while we can call this DFS function recursively to find the LCA. And before we find the LCA, we need to initialize it. So LCA node will be none. And then finally, we want to return the LCA node. And we will call the DFS recursively using the loop node. So we have node here. Okay, and P and Q will be passed on to this DFS function. So we don't need to specify P and Q as argument here, but the node will be changing recursively. Because this function will be called recursively, we want to think of the end state, the terminal leaf node ahead of time. So if node is none, we return false. And then we want to implement this part, return true if POQ is in the kernel or in the subbranches. So for the subbranches, we will use two variables. So let's have left and right subbranches equals to DFS node left and DFS node right, respectively. And if P equal to no, or Q equal to no, or left branch or right branch, we return true. Otherwise, we return false. Now we're going to implement the two conditions for LCA part. Since it needs the two sub-branches, so we will be implement it after we have the two sub-branches right here. Okay, right here. And there are two conditions. So condition 1 is when left branch and right branch. And condition 2 is when P is in null or Q of N, or Q is in null, and then there's an N left branch or right branch. So these are the two conditions. So now, if condition 1 or condition 2 is true, then we know we have found the LCA. So LCA null equals to the current null. And then we have found the LCA. And then we want to do an early termination if we have found LCA. So if the LCA is found, it's not known, return false, and this is early termination. Okay, and that's it. That's our code for this lowest common ancestor. Just to make it a little bit more legible. Okay. So now let's test this code to see how it works. We submit and done. 72 milliseconds. Finally, we'll analyze the code for complexity. So this code, recursion, has time complexity On, since we need to traverse through all the nodes, just once for all the nodes. But in the worst condition, we need to traverse through all the nodes. So that's On. And for space complexity, it's also On, since the stack for this recursion will be On in the worst condition as well. And that's all for this question. The solution provided here requires some understanding about the binary tree structure, the use of recursion, and the depth-first searching mechanism, as well as the logic of these two conditions for LCA. Hope you find this video to be useful. Please subscribe and stay tuned for more videos. Hope to see you next time, and goodbye.